can do that. All right, ladies and gentlemen, we're recording the lesson so I can put it up on the website for future reference. So keep that in mind.
Right now?
Today, yes. So keep in mind today what we're going to do is learn how to add and subtract. We've already multiplied. You guys did that on the worksheet last night and the day before, and then we divided on yesterday's worksheet. So we've taken care of those two operations. Now we're going to take a look at what it means to add and subtract those. So in order to add and subtract, they must be what we call like terms. And like terms means that you have the same number under the radical. So it's kind of like working with variables. I can only add an x with an x. I can't add an x with a y. So an example of like terms is this 3 square roots of 5 plus 7 square roots of 5, because they both have the square roots of 5. So if I handed you 3 square roots of 5 and then another 7 square roots of 5, guess how much you have? A lot. You have 10
Square root of 5.
Where are we getting the 10 from?
Adding
3 and 7, ladies and gentlemen. It's just like adding coefficients. If I gave you 3x plus 7x, you would simply call it 10x. We're going to call this 10 square roots of 5. Gentlemen.
We're talking about that off.
That's fine. Let's listen today. Unlike terms is anything with unlike radicals. So if we look at the first problem, we obviously can't add everything together, but we can add the parts or subtract the parts that are like terms. So 4 minus 9 is a negative 5, and then it's just square roots of 3. The radical will never be eliminated, ladies and gentlemen, okay, unless it completely cancels out. So 4 square roots of 3 minus 4 square roots of 3 would give you 0, but you're never going to subtract and cancel out this radical simply because the coefficients have subtraction. There's nothing to add the 2 square roots of 7 to, so it just stays 2 square roots of 7, and that's what our final answer is going to look like. So it's just like when we would be combining x's and y's, we would still have x in one position, y in the other. So we're not going to get these down to just one radical. Most often we're going to have 2. If we look at example 2 here, it doesn't look like anything combines, but what you have to do is simplify each expression first. You have to make sure it's in simplest form. So when I look at the 5 can't simplify down any farther, but I know 20 can start to break down. And so I had someone in third hour say 5 times 4, and I thought that was a pretty smart way to break it down. 4 is a perfect square, so it's going to make my simplifying a little bit easier. But also, guys, in order to add these together, I need both of them to have square roots of 5, correct? So if I start with that 5 there, there's a good chance I know I'm going to end up with like terms. And in fact, we do know that because 4 is 2 times 2. So that 2 is going to come outside the radical. So what we have is the first term stays the same, 3 square roots of 5. There's no coefficient here, guys, so keep an eye out for that. This is minus 2 square roots of 5. All right? Combine those. 3 minus 2 is 1. So we simply call that square root of 5. Zena? You could. But it's kind of like when we had x. X was the same as 1x. I didn't have to have it there. So it's the same with radicals. 1 square root of 5 is the same as square root of 5. All right? I believe the next 2 problems on your paper are on your own, so please get going on those. So for the first one, 2 does not simplify, but I would love to have a 2 here. So start with that as your first factor. So we have 2 times 25. At that point, you've found your perfect square. So this stays 6 square roots of 2. The 5 comes out, and we have 5 square roots of 2. I think most of you, as I walked around, didn't have much problem coming up with that 11 square roots of 2. When we get to B, it's no different whether it's 2 terms or 3 terms. I've got to break everything down. So if you notice this 8 square roots of 7 doesn't simplify, so I'm kind of bringing that down. What I want to do now is treat this kind of like problems that we did the day before. Here's 4 times 7 because it gives me the 7 I'm looking for. This is a pair of 2's, just like before, ladies and gentlemen. That coefficient, that number up front, is multiplied by anything you pull out. So this isn't minus 2 square roots of 7, it's minus 4 square roots of 7. For the next one, for 32, oh, I did 8 times 4. But I can kind of make that up. There's my pair of 4's. Not many times are we going to see examples where all 3 of the terms simplify to the same value. So we're going to combine the 2 that do. We have 4 square roots of 7 minus 4 square roots of 2. All right, any questions there, guys? So basically, I'm giving you 3 problems from yesterday's worksheet and putting it into one. Got it all written down? All right, let's take a look at multiplying. We can give you multiplication with this addition 2 ways. One is simply distributing, and the other way is foiling. We'll take a look at the foiling on the back side. But for right now, guys, you're simply distributing. All right? So I'm going to take square root of 5 and times it by square root of 15. We were doing this on yesterday's worksheets and the day before, and you simply called that square root of 5 times 15. When they're both radicals, they can both get put under the radical. But when I go to multiply square root of 5 times the 3, I cannot, Jacob, put those together. I have to keep them separate. Okay, so it's kind of like multiplying an x times a 3. We write those as 3x. So this is 3 square roots of 5. Now what I have to go is go back and simplify what I did at the very beginning. So anytime you do a radical times a radical, because you've created something new under that radical, you have to see if it simplifies. So there's the pair of 5's that I needed, and 5 comes out. I'm left with square root of 3. 5 is prime, so it doesn't simplify. So that last one is going to stay minus 3 square roots of 5. Even though they both contain 5's and 3's, look closely, it's not the same radical. And so that's my final answer. All right, I need to do 2 square roots of 8 times 3 square roots of 10. What do we think that's going to look like? I heard someone say 6. Perfect. Outside times outside. Integer times integer. And then, guys, you can call it square root of 80 if you want, or keep it as 8 times 10, whichever is easier. You're not getting really large numbers here, so keeping them together as 80 is probably fine. I then have to do the same thing. 2 square roots of 8 times 4 square roots of 6. Now, Mr. Clem, during third hour, said he called that 48 when he was working things out ahead of time. And here's why. 48 is 16 times 3. And what do you know about 16? It's a perfect square. So that 4 is going to get multiplied by that 8. Now, guys, I do feel like I'm going quickly, and some of you are having trouble keeping up with my writing. But am I teaching you guys anything new once I get that 8 square roots of 48 up there? No, it's just that simplifying process. If you're still struggling with that, guys, I need to be seeing you before or after school or during seminar. 8 times 10 I need to break down. This is 4 times 2. Guys, I usually take something like 10, and because I have a 2 here on the right, I'm going to put the 2 on the left. I like to put my pairs close together so I don't lose track of them. Just little things I do to keep my factor trees a little bit neater. This 2 comes out, and this 2 comes out. You're going to have both of those come out, and they both have to get multiplied by the 6. So 6 times 2 is 12, times 2 is 24, and we have a square root of 5. Pretty good? All right. Ladies and gentlemen, I would like you guys to turn to the back side. What do you mean add those last 2? Yeah, it's just a plus sign because they're positive. We can't combine any terms there. Ladies and gentlemen, I'd like you to jump ahead and try number C on your own. I want you guys to try that one. What? I want you to try that. Never mind. Let's go back and take a look at All right. 2 minus square root of 3. Quantity squared. What does it mean to have something squared? 2 of them. So we're going to write this out as 2 minus square root of 3 times 2 minus square root of 3. There's no distributing of an exponent, ladies and gentlemen, that doesn't exist. But what I can do is write it out 2 times. So now what is 2 times 2? What is 2 times a negative square root of 3? Negative 2 square roots of 3. Why is it not square root of 6? Good job. We've got one non-radical, one radical. I cannot actually multiply those digits together. It stays separate. So the same thing here. I'm going to do negative 3 times, or negative square root of 3 times 2 is a negative 2 square roots of 3. So, all the arrows?
Yeah.
I'm just distributing. How did you learn how to distribute in Algebra 1? Isn't that what I'm doing first? Outside, inside, class? Okay. Now I have to do a negative square root of 3 times a negative square root of 3. So what's a negative times a negative?
Positive.
And what's 3 times 3?
9. Wait,
9.
9.
Alright, so ladies and gentlemen, let's take a look at some things that we can do. Can we combine these middle terms?
Yeah.
Can I simplify those terms? No. 3 doesn't simplify, but can I take the square root of 9? What is the square root of 9? Good job, Grace. It's a perfect square.
Oh, then you add 4.
So, ladies and gentlemen, we've been combining radicals, and that's what we kind of did on the front side, was look for radicals that can combine. Are we sometimes going to end up with integers that are added together?
Yeah.
Yes. So, Jacob, what will we combine together? And so 4 plus 3 is 7, but we can't forget the radical. So that radical still goes at the end as minus 4 square roots of 3. All right, let's take a look at number 6. Number 6 is full of radicals. You see probably about 3 or 4 of these on the worksheet today. It's no different than what you did before, guys. Here's one problem from yesterday. 4 times 3 is 12, and 2 times 8 is the square root of 16. Don't lose that radical in the multiplication. Keep track of it. I then have to distribute to the next radical. 4 times, this is a 1, ladies and gentlemen. There's no outside number, so it just stays 4. But 2 times 5 is 10. Negative 3, or negative square root of 3 times 3 square root of 8 is negative 3 square root of 24. And then we need to do negative square root of 3 times positive 5, or positive square root of 5 is a negative square root of 15. Jacob, you got this written down? Let's get going. Rem, you got this? All right. Does square root of 16 simplify?
Yep.
To what?
4.
4 times 4. That's going to become 48. Does 10 simplify?
Yep.
Well, I can break it down to 2 times 5, but are there any perfect squares there?
No.
So this is just going to stay plus 4 square roots of 10. What does 24 break down into? 3 and 8, 2 and 4, and this is 2 and 2, so there's a pair. That has to come out, guys. Don't lose track of that 3. So this is negative 6 square roots of 2. And then does the 15 simplify? No. 15 is 3 times 5, but are there any pairs there?
No.
Ladies and gentlemen, can we combine any of these terms?
No.
So you will have some problems that's what they're going to look like. So I do believe if I change to the